In this video, we're going to add an insert function to our linked list implementation that we've been working on. So we already have a function to add a node to the head. We have a function to be able to print out our linked list, but we would like to have the ability to insert a node anywhere in our linked list so that we can maintain some sort of sorted order. So let's go ahead and get started with that. You can see that I already have contactlist.h open, contactlist.cpp, and also contactlist.app.cpp. So those are the three files that we'll be modifying today in this video. So the first thing we're going to do is just add in a function prototype here inside of contactlist.h. So below our print list prototype, we'll have a void returning function. So our insert function is going to be a void returning function, and we'll just call it insert, and it's going to have the exact same formal parameters as we had for add to head. So it's going to be a const std : string. So we're just passing in a string, so a name for our particular contact is going to be passed in, and then inside of the function is where we'll actually create the contact node. So we're just passing in a name as a string by constant reference, and then we'll construct the node inside of the function. So let's go ahead and save that. That's the only thing we need to have in contactlist.h. And so let's go over here to contactlist.cpp and start writing the code for the function. So we'll have void. It's a void returning function. It belongs to our contact list class, and we'll just select insert from there and have const string ampersand here, passing in that name by constant reference. So we'll just use the identifier here of name, and that satisfies our function header. And now what we need to do, the very first thing that we'll do inside of this this function body is create a new contact node. So we'll have a pointer of the appropriate type, a contact pointer, and we'll call it new node, and we'll create that node out on the heap. So it's a new contact node that we're creating, and we'll pass in the name there to the constructor. So that's all we need to have there to construct a brand new node out on the heap and have a pointer referring to that node. So the next thing we'll do is just write a little bit of pseudocode just to match up with what we were doing logically in the previous video. So in the previous video we just logically showed how to insert a node and showed what pointers would need to be updated and how to go about doing the traversal. So I just want to kind of match up with what we did in that video. So we had three different cases. In case one, we were dealing with inserting into an empty list, and then we had case two, which we were inserting into the head, or we'll say insert at the head, insert at the head of the linked list. So it's not empty, so we'll say maybe not empty here. And then case three, our third case, was whenever we wanted to insert somewhere other than the head. So insert maybe after the head is the comment that I'll make, and we're dealing with again not an empty linked list. So we have not empty there. So those were our three cases. So in the first case here, what we'll have to do is just test to see if we have an empty linked list. And the way we go about doing that is just testing to see if our head pointer is in fact equal to null. And I'm going to just use 0 there for the null representation. And we'll have inside of there, we'll just simply update what head is pointing to. So we want head to now point to our new node. Well, we have our new node pointer, so we can just set head to point to new node. Okay, so we're just basically copying the address here that was in new node over to our head pointer. So they're both pointing to the same thing. And then I'm going to let's make this an else statement here, and we'll do an open brace there. And let's see, we'll do a close brace, and we'll put these comments inside of that bit there. So the first thing that we're going to do inside of this else statement here is just create a couple of pointers that we'll need. So we'll need to have a contact pointer for our current node, so whatever the current node that we currently are looking at or examining. And initially that current node will be set to the head node. And the other pointer that we'll need to create is a contact pointer called trail, or you could call maybe previous. And this will be a pointer that simply points to what current was pointing to before we updated current during our traversal. So if you haven't watched that video that shows the logical representation of what's going on for an insert, then definitely watch that one and then come back and watch this one if this is seeming a little bit unclear. If it's clear, then thumbs up and keep going. So we'll say that trail is going to be initialized to null. We don't want to set it to null. I mean, we don't want to set it to head. We want to set it to null. And then the next thing we need to do is an actual traversal. So I'll go ahead and put a comment in here. We'll need to traverse the list to find the insert location. So we'll traverse the list to find the insert location. And so the way that that's going to work is we'll just have a while loop here, and we'll say as long as our current node is not equal to null, so basically we haven't fallen off the end of our linked list, then we can still keep updating current and still moving through trying to find where we should be inserting our new node. So what we need to be doing inside of this while loop is testing to see if the current node that we're looking at, so we'll dereference our current pointer and then get to the name data member, which is really the only other data member besides next that we have in each one of these nodes, and see if that current node's name is greater than or equal to the new node's name. And if that's the case, we can stop our traversal at that point in time because we found the location of where we should be inserting our node. Our node belongs before this current node that we're currently pointing at, if that condition is true. So we'll write a statement like this. We'll say if our current node, so we'll dereference our current node by using the operator there, but that also allows us to do a member access. So we'll do that, and we'll access name, and we'll see if that name happens to be greater than or equal to the new node's name. We could actually say new node and do the member access operator name here, or we could just use name. Either one of those would suffice because we did pass in the name here through this formal parameter here. So it's really up to you if you wanted to have new node and then member access operator and then name, or just have name there. But I think that's a little bit clearer. And then inside of this if statement here, what we're going to do is just simply break out of our while loop. We found the location where we need to insert our node. If that turns out not to be the case, we'll have an else statement here. And in the else statement, we need to be updating two things. So if you remember from the video on the logical representation, we need to be updating that trail pointer first. So we need to have trail being moved up to what current is currently pointing to. And then we can update current. And you got to get these in the right order, otherwise it doesn't work out so well. So trail gets set to what current's currently pointing at, and then we can update current to be pointing to current's next. So we're driving that current pointer forward using our next pointer. And so that's the only thing we need to have in terms of our traversal to find the position of where our new node should exist. And now we can look at these two cases here. So in case one, we will test to see if the current node that we're looking at happens to be our head node. If that's the case, we know that we're doing an insert at the head. And if we're doing an insert at the head, we need to set new nodes next. We need to set that to be equal to head, and then we'll need to reset the head to the new node. So we'll set head now equal to the value there that we have for new node. So that's the only thing that needs to go on for that part. And then we'll have, I guess, an else statement here. So we'll have else, and then we'll have our second case here, our third case. And in that case, we're looking at inserting somewhere after the head. So for this, we'll say that we need to do what? We need to set new nodes next. We need to set new nodes next. And if this isn't clear, go back and watch that video on the logical representation, because I think it'll make it a lot clearer in terms of how these pointers are being updated. But fundamentally, we got to set new nodes next to current. Okay, because what we're saying here is that our new node belongs in between the current node. So the pointer, we have a pointer called current that's pointing to a node, and we need to have our new node sitting in between that node and our new node sitting in between the current node and sitting in between the node that says trail. So after trail, but before current. Hopefully that makes some sense. So we got to set new nodes next to current, and then we got to set our trail next. So our trail next, that particular node's next to new node. And that's the only thing that we need to have going on. I guess the last thing we could do here is increment size. So let's go ahead and just increment size here outside of the the close brace. I guess before the last close brace, because that's our function close brace, but below this brace here that was associated with our else structure. Alright, so that's all we need to have there for our contact list. So let's go ahead and save this contact list.cpp, and now we'll go over to contact list app. And in contact list app, we'll just change up one thing here. Instead of doing our add to head function here, or calling add to head, we'll simply call our insert function. So we'll change this bit here to just calling our insert function whenever we want to insert a new node, and that way we can maintain a sorted linked list as we insert those nodes. So we'll go ahead and save this and build it, see if everything builds okay. And it looks like everything built okay. So let's go ahead and run this, type in some names, and we'll put in some names that are not in alphabetical order. So we'll say that maybe we have Mary, we'll have Bob, we'll have Sally. Let's see, what else do we want to have? We want to have maybe Larry, and we'll put in, I don't know, I'm trying to think of some, it's hard to think of names sometimes. We'll put in the name David, and we'll also put in one more name. We'll put in Roger. So those are our names, and we'll press Q to quit, and you can see that we do have these names in alphabetical order. So Bob, David, Larry, Mary, Roger, and Sally. So after you play around with this program a bit, I would encourage you to maybe go in and use the debugger just to see what's going on in memory, see how those pointer values are being updated, see if it actually makes sense in terms of what's going on in memory. And I think that just makes you a better programmer if you actually understand what's going on behind the scenes. So that's it for this video.